Our final presenter will give us a perspective on managing color volumes on different displays for different use cases and the importance of proper color management. So Matt Lathrop is the lead architect and project leader in Studio Lab at the Walt Disney Studios, where he's been for the past 3 years. In this role, he works on supporting productions across the company with new and innovative technologies from the industry. Before joining Disney, Matt gathered experience in various innovation groups across multiple industries. So like me, he's been in aviation before, light field displays, focusing on solving complex problems and driving technological advancements. He holds a BS in computer science from Stanford University. So let's give a hand to Matt.
30 minutes. Don't worry about it. Alrighty, let's move this forward. I'll agree with Harris. Nothing quite makes your skin crawl like having someone read your bio out loud to a room full of people. All right, let's see if I can get to. Oh, well, okay, perfect. All right. Well, as I said, I'm Matt Lathrop. I work in Disney's Studio Lab. The Studio Lab is a group within Disney that focuses on partnering within industry to bring the latest innovations into the studio. With this project, I do want to reach out and thank some people who aren't here. Bill Chernega was the tech lead from Studio Lab on this project. Sally Hattori was executive oversight. And then, of course, we also partnered with LG on this on this work. So in the audience, you have Joe Cates, Jin Hong Chung, and Yongsun Kim. So to kind of set the stage here, I'm going to present you guys with something that I'm sure many of you are familiar with, setting up a TV for the first time. So this is me recording an LG TV, and you go through and you're going through the menus and you're clicking through and setting each individual setting. And, you know, at Disney, this is really important. We do this to every single display we have. Conference rooms, review rooms, it doesn't matter. We're going to set the settings of every single display to a defined standard. Now, those standards might vary depending on who you ask, but there is a standard for every display. And this is because a lot of times we have what we call color close applications. So it's where we're not actually trying to make color decisions. There's no real reference that we're looking at. We don't have a reference display in the room, or maybe we do, but that's not what we're looking at. So this is more for when we want a bigger display. We're going to use a consumer display, something like that. We're just in a conference room, executive's office, etc. But we still want to have as accurate of color as possible. Now, if this was just a few displays, no big deal. You grab the remote, you set the settings, something changes, go check. It takes a few minutes to go check the settings. But if you scale that to hundreds or thousands of TVs across the company, now we have, you know, teams of people whose job it is to do nothing but go around and spot check settings and respond to support calls of people saying the color looks wrong. It's a really, you know, pretty time-consuming process. Our engineers estimate about 10, 15 minutes spent per display for LG displays on setup, calibrating, you know, setting all the different settings on the display. And it's also, you know, somewhat error-prone, right? If you're going through with an infrared remote, it's clicking and, you know, you might make a mistake. And what's more is, you know, if someone notices something that's off, they're going to give a support call. We're going to have to send someone in person to go and adjust the settings. And, you know, that person's going to have to, everyone's waiting in the room for them to come, make the change. I think actually Lawrence was talking about in his keynote, you know, he had a similar situation where, you know, a director was looking at something that looked wrong. And, you know, now you're trying to guide a director or someone, you know, some very high level person through TV settings going, well, is the gamma set to this or, you know, whatever else it is. And so what we came to is we started with this goal of, well, can we just reduce the time engineers spend navigating menus on a display and provide a single page where every setting could be, you know, validated at once. And it was a nice goal, but we started talking to our different stakeholders around the studio, and we realized that this is really kind of not the whole problem. It's kind of just part of the problem, and we really needed to think a little bit bigger. Like I was saying, it's not just the setup process. It's not just looking at the screen once and going, yep, that all looks correct. But it's actually more ongoing validation and things like that. So we kind of reevaluated the needs from there, and we came up with these two goals. First was to accelerate the display deployment process. As I said, 10, 15 minutes doesn't sound like a lot, but per display, scaled to hundreds, takes a while. And then the second and probably more important one was ensuring the displays always have the appropriate settings for the current use case. So whatever the room is being used for, it's on the correct settings for that review, for that use case. So let's dive deeper into the first one, the accelerating the display deployment. Our typical deployment process was something like this. We unbox the TV. We do a burn-in period to let the colors stabilize. We apply all of our studio-defined settings, and then we calibrate the display using Kalman. That display is then ready for deployment, and then we would check that calibration after a fixed interval of time or whenever we get a support call, whatever comes first. What we found, though, is that this point here in the middle is actually where we made most mistakes. And if you make a mistake there, that means you have to redo your Kalman calibration, which, can take hours. And what's more, what happens if, there's a remote in the room and someone picks up that remote and starts making changes? Now, one solution is you just take the remote away. But that doesn't actually work for all of our use cases. There are some valid reasons why, someone in a room, a creative, may want to adjust the settings. Maybe there's an actual reference display, and they're working on a production like Loki, which had a really green color palette, and they maybe want to do a perceptual match to an actual reference display for that particular production. And if they make those changes but don't change them back, then the next people to come in the room, all their work's wrong. Which brings me to the second point, the second goal, ensuring the displays always have the appropriate settings for the current use case. So this means we need ongoing monitoring, not just the initial setup. And it's actually really a lot higher value than just the initial setup, right? The initial setup, we're saving 10, 15 minutes per display when it's purchased. But that ongoing support and monitoring, that's where the real value starts to come in on this project. So we kind of took a look at this and we realized there's not a lot we can do by ourselves. The displays don't really have a way to talk to them. They're consumer displays. So we approached our partners at LG and said, hey, could you help us? And they said, thankfully, yes. And they pointed out they have an SDK, an existing SDK called Connect SDK, that allows remote communication to the displays over the network. It allows for you to get and set things, so it's not just pushing settings to the display, but actually retrieving those settings from the display and seeing what the current values are. It's currently powering their iPhone app and I think probably the Android app as well. So it's likely to continue to receive support, which was important for us. But it did kind of lack the comprehensive picture settings we were looking for. It had volume, which is great, but that's not really what we're after. We're really trying to think about, all of the deep picture level settings that are on the display. So LG went back and they added 58 new settings to their API for us, which was really, really appreciated. They provided us with some testing scripts, so some Python scripts that we could go through and start to get and set and test those different values to see how they were working. And once we had kind of validated, okay, yep, these settings are working, we're able to control the settings we want. Now let's move past that and start thinking about how we're going to deploy this at Disney. So the first thing we wanted to do was to build a communications library just for the display, communicating to the TVs. So we kind of wanted to abstract away all the complexity of talking to the TV, handling certificates and codes and what everything's called. And so we started the Disney Display Communications Library. Not a catchy name, but that's fine. And what this library would let us do is take all of the complexity and capture it in a JSON file. So there's kind of a little excerpt there. I don't know if y'all can actually read it. But we defined all of the different settings available on the display through this JSON file. So you can look here, see here, we've got, the name of the setting, the category that it belongs to, which here is blank, but, the range, this is a really simple one, brightness, the URI that's sent for sending and receiving it. And, it's a really straightforward mapping here. Brightness maps to brightness. But that's not always the case, right? For example, I think color maps to color depth or something like that. And pixel brightness maps to backlight. There's a few things that get a little bit, hairy around it. But once we had that, now if there's changes made, new TV comes out, it's got a new setting, new thing you can tweak, or the name was changed, etc. It's really easy for us to go in, make the change, and push those settings out for the new generation. So once we had this sort of base communication, we started to work on a command line interface. So our V1 was kind of hints at what might be coming later in the presentation, but for V1, we focused on a CLI that could communicate over the network, but directly from a laptop to a TV. So you would, in Disney's case, a lot of times we were actually having to plug an Ethernet cable directly between the laptop and the TV because, we're on a corporate network. They don't necessarily open every port for us. The traffic is, they may not, want to have a bunch of IoT devices on a corporate network. But we built this out. It worked very well. You were able to plug things in. We had autocomplete. And we also introduced the concept of a profile. So what profiles would let us do is capture all the current settings of the TV into like a JSON file as well. And so we could go through and we could see all those settings, what they were set to, and then apply those again later. So I'm going to give you a quick demo of that. Let's see if we can play this video. All right. So what we've got is an LG G3 TV with the latest firmware. We've set it to some really obviously bad settings just to accentuate the change here. So there's a 4:3 aspect ratio, really high green tint. And in a second here, it'll cut. Let's see. There we go. And we've got a JSON file with all of the standard Disney settings, all the different values. I know you can't read it, but they're all there. And all the values that we prefer to set those to. And what you'll see on the other side is our command line interface. We've got, it says TV settings set all in the JSON file. We hit enter, and now the TV no longer has the green tint, no longer has the 4:3 aspect ratio. You're able to change it all in one keystroke. We can also change individual settings, and we do have that autocomplete. So we've got, set color, and you can say, okay, I meant color depth, and go through and set, a particular value, in this case 20. And again, I don't think you'll be able to see it, but in the bottom, it did change to 20. But if maybe you're not in the same room as the TV or don't want to pull up the menu to check that it changed, you can actually just from the CLI get that same setting value to confirm that the change took effect. So here we're going to get the color depth value again. You can see, yep, it's 20. Furthermore, we can go and save these new settings. Let's say this is, the values that we want to use on a new production or something like that, to a JSON file. We can go and pull that JSON file up. And if we search through it for color depth, you'll see how maybe y'all won't see, but it does say 20 there. Right in there. There you go. And then, of course, we could apply that JSON file just like we did the first one to the TV, change the settings. All right, so once we did that, the immediate feedback was awesome. I don't want to be in the same room as the TV. I don't want to walk to the TV. That takes time. What if it's, TV on an executive's yacht? Real concern that we have to worry about. What if someone changes something? Can I just get an alert that something changes? I don't want to have to keep checking. So all of that led us to kind of re-architect our solution to a centralized backend. So we're going to go through this diagram. The big key here is here in the middle, the async web server. That's sort of the brains of the operation. And so what we did there, that's where all the code is. That's where all the smarts of how to change a request into a request to a TV takes place. Let's start over at the user end. a user makes a request through an application. So that could be a GUI, that could be a command line interface, but maybe the request is set this setting on the TV. First thing we're going to do is make sure that user is actually authenticated and able to make that change. So we integrated with our enterprise IDP provider. So we're able to go and check and say, okay, yep, that person's actually authorized to use this application. We're able to make those changes. And once that's resolved, that application makes its API call to the async web server. So now that web server is going to go about trying to process that request. Now, there's two different paths here out of the async web server. There's the one that leads to the database and one that leads to the TV. So for most things like setting a setting, things like that, you're going to want to reach out to the TV, right? So if I want to set a setting, I want to update the settings, I want to get the current value of a setting, all that needs to actually go and talk to the TV directly through the Connect SDK API. However, there are things where maybe we don't want to actually reach out to TV. It could really load down the network. If you tried to say, get the settings of 100 different TVs all at once, that's going to put some really heavy strain on the network to go and ask and resolve that request. So instead, what we started having is this database where we store our templates. Those are all the different values for every setting, the ranges. So if you're just trying to understand what the valid settings are for a TV, you don't need to go ask the TV that question. If you want to know what the last known value was, we actually in the async web server have sort of a cron job that runs at a fixed interval, and we'll go through and ask all the TVs, maybe once an hour or once a day, what are you currently set to? And so from that perspective, we then can know what the last known settings were, and that's where that sort of notification can come in, and we can say, oh, this setting was changed. We might want to send a Slack notification or something to someone to say, hey, you might want to go take a look at this TV. Someone changed it, and make sure that it was for a good reason. But of course the TV can respond, and then, it kind of just flows back all the way through to the user, or the database can send a response and again flows back to the user. One thing I want to call out that's not particularly obvious from this is these VLANs at the bottom. The TVs are IoT devices, no slight at anyone, but generally corporate IT and IoT devices don't mix very well together. So all of our TVs are put onto a restricted VLAN on our network where no one else other than those that are explicitly authorized can access it. So basically it's, a few engineers, and then everyone else has to talk through the web server there in the middle to actually communicate to a television. And so this protects us from having those TVs being able to go out and reach other services on our network, or have people that maybe don't know what they're doing and accidentally start trying to mess with the TV. So, of course, this led to the CLI v2. We need to go through and update our CLI to, instead of talking through the television directly, it would actually go through and talk to our backend. The big changes here where we were, of course, now able to remotely talk to the TV. So our backend is actually hosted in AWS. It's not even on-prem. So anywhere in the world, you can talk to that API as long as you're connected to our VPN. And you can, control those TVs. And similarly, the TVs could be anywhere in the world. Another thing we added was this sort of pre-printing of the tables. It's a big quality of life improvement when you're trying to look at data. And then we also had groups of televisions. That was a big piece of feedback. It was like, hey, it's great that I can control one TV, but if I want to just push settings out to, 10 TVs at once, a bunch of different rooms, can I just do that with one command? It's pretty easy to do. So we added that functionality as well. So let's take a look at the V2 CLI in action. All right. So now we have two LG C3 TVs this time, running the latest public firmware. Anyone can download this. We can list out the TVs, see what's connected. We can see the serial number, MAC address, different, what profile they're currently set to, all that sort of information. And what we're going to do here at the bottom is we're going to change the picture mode of the TV on the right. So you can see now these are really different. We set this to the vivid picture mode. I think we kind of accentuated the change here for the demo. We can also set another setting like tint to -50 just to make it super obvious again. So, big changes between the two here. So after that, we can actually go and I think we're going to save a profile. Yep. All right. So we're going to save the current state of this TV as a profile called LG Demo. And from there, we can compare. Let's see. All right. LG Demo. It would be nice if I was actually typing this. But all right. So, yep, we're going to compare the left TV, so the one we haven't changed, to the profile LG Demo that we just saved. And we'll see, okay, well, here's all the different settings that changed. So, we didn't change all these explicitly, but a lot of these changed when we changed the picture mode, and then the tint obviously changed directly. Now, if we want, we can go ahead and set the left to the profile of the LG Demo. So now these two should have the same settings. And then I think we're going to go to groups. All right, so we're going to list out the different groups now. Oh, look, we've got one LG story room. So that's these two TVs together. It's got, two members. We can list out the members here. I say, yep, LG Demo right and LG Demo left. Those are our two TVs. And now we can actually go and apply, before we started this, we saved LG good, and in one keystroke can go and apply that setting, and both our TVs are now back to our kind of starting values. So that's it for the demo. So I wanted to, before I wrap up, kind of go through our GUI as well. So we haven't finished our GUI. We're still focused on the CLI. A lot of our users are engineers. They're comfortable with the CLI. But, we're all humans. GUIs are pretty and easier to use a lot of the time. So this is the designs that we have. We're still in progress, like I said, on building it out. But you've got a home page where you can see a lot of the same information that you could see by just listing out the TVs like I showed in the demo. But with one crucial thing here is you can go through and you can have a drop down to select different profiles and really quickly change the profile of a TV. You could also click on an individual TV to see what the current profile is set to. And then here we are listing out every setting that's currently sort of out of spec. So, the profile, we know what it's supposed to be. We know what the current settings of the TV are. So, what's the current value? What's the appropriate value? And then we have a reset button that you can use to set the setting back to the profile. Of course, we can just take manual control over the TV. So this page is basically our original goal that we set out to. Like, okay, can I just see all the settings on one page? Well, yes, here you go. You can go through and you can change all the settings, drag sliders around, and then apply those settings to the display. Of course, we brought over our groups functionality as well. So this is just a listing of different groups with their settings, and you can set a profile for a group. So that's where we are in the project so far. Looking forward, there are some things that we'd love to do. Deeper integration with Kalman would be excellent. We use Kalman to calibrate all of our displays. So if we can go through and have a deeper integration, one that maybe allows us to back up the LUT that Kalman's calculating and push that and save that with the profile as well on an individual TV basis, that would be really great. We've also talked with LG about having even deeper pipeline controls of the display pipeline. So, there are things that don't make sense to offer into a consumer's TV display on-screen menu, but we might be able to expose over an API, something like the LUT upload. And then an event-based API. Right now, it's all push. We have to have a cron job to go through and manually pull the settings and understand what's changed. It'd be really great if instead we could just get a notification from the TV over the network that says, hey, someone changed this setting, and then, we can kind of notify people instantly. That is it. So I want to thank everyone who helped with this project, the whole Disney team, the whole LG team, and of course our stakeholders at Disney for providing feedback for us. And with that, I'll open up for questions. He had his hand up. She had her hand up. Mike's coming around.
Are you, great project, very useful. Are you publishing any of this on GitHub so that you can get collaborative development?
Unfortunately, the man you need to ask is directly diagonal to you. That's Joe from LG. They are the ones that have the main sort of API. We probably won't publish our sort of communications protocol, but I believe the intention is Joe didn't get a mic, but I believe the intention is to yes. I don't know. You can. He's nodding yes. So I believe the intention is for LG to publish this so that others can use it. Most of the Connect SDK is already public, so it would just be adding those additional things.
Hi. Also a great presentation, by the way. My question for you, maybe I missed the first portion of this demonstration. Is this for Disney Plus when we're sending out our platform files and it's a manual profile saying, hey, this is the creative intent of what we need the TV to look like?
So this is primarily focused on displays that Disney owns. So we're doing this all over an IP network because we know that all of our displays we can put on our network and have total control over. I don't think consumers would probably be okay with us having that level of control over their TVs in their homes. I don't think LG would expose that to us. But I do think that there is sort of a parallel path to this sort of project where we could have, maybe the Disney Plus app talking this protocol, but internal to the TV so that when certain of our content comes on, we could adjust the settings to our desired, calibrated settings. That would be an interesting thing to do as well. Any other questions? Uh-oh. One there and one there. I don't know how much time we have left. I think we're technically...
Great presentation. I was just curious, are log files generated? And if so, how are they accessed?
Log files? We're not doing audit logging right now. We're still kind of in a more of a prototype phase. But it's a good idea. We probably should have some audit logging. There is one question in the back, but I'll let you go and then we can do that one.
So LGs have multiple modes, ISF dark, ISF light, cinema home, all this stuff. So is this per mode you can set?
Yes. So the way LGs work is basically they have a number of slots that you can set. So every input with every mode is an independent slot that we can set and profile and load whatever profile we want into it.
Does the API give you the control to schedule firmware updates? Because those happen a lot.
No, not that I know of. Actually, one of our engineers actually asked that this morning. Was like, it'd be really great if we could do firmware updates through this API. And I was like, oh yeah, that would be cool. But no, it's not currently in there. Our approach is we don't let them access the internet unless we want them to. So they don't know that there's a firmware update coming until we manually allow it to connect to the internet for a moment.
Great. Thank you, Matt. Thank you, everyone, for the session.